You clicked because you saw it. The East Coast. The next 10 days, a forecast alert that most people scrolled right past. Here is what stopped me. Forecasters at the National Weather Service and the Climate Prediction Center are not watching one storm. They are watching a pattern flip, a buckling in the jet stream that can lock a storm track against the entire Atlantic seaboard and hold it there. That is not hype. That is the kind of setup the Climate Prediction Center flags in its 8 to 14 day outlook, the product almost nobody outside the field ever opens. I found something buried in that trail that reframes the whole thing. A number sitting in the ocean off the coast right now, measured by real instruments that most coverage never mentions. Stay with me, because the last clue is the one that decides how bad the next 10 days get, and it touches you no matter which state you are watching from. I want to tell you the exact moment this clicked for me. I was reading a forecast discussion, the raw text version the meteorologists write for each other, not the polished graphic. And one forecaster wrote a single line about a blocking signal showing up in the ensembles. I read that line 3 times, because a block is the difference between a storm that passes in a day and a pattern that refuses to move for a week. So let me walk you through the trail exactly the way I found it. The first clue is not a satellite loop. It is a map almost nobody looks at. Every single day, the Climate Prediction Center, a branch of NOAA based in College Park, Maryland, releases something called the 6 to 10 day and 8 to 14 day outlooks. Most weather apps never show you these. They show you tomorrow, maybe the weekend. But the professionals are already reading the shape of the atmosphere nearly 2 weeks out. When I pulled those outlooks, the story on the surface looked simple. Cooler than normal air pressing down into the eastern third of the country, a tilt toward wetter conditions along the coast. If you only read the headline, you would shrug and grab a jacket. But that is not what the outlook is actually saying. The outlook is a fingerprint. And the fingerprint it was showing is the classic signature of a jet stream that has stopped flowing smoothly west to east and has instead folded into a deep trough over the eastern United States. Here is why that matters. In plain terms, picture the jet stream as a river of fast wind riding along the boundary between cold northern air and warm southern air, usually about 30,000 feet up. When that river runs straight, weather systems zip across the country in a day or two. Rain comes, rain goes. But when the river buckles, when it digs south into a giant U-shape over the east, storms slow down, they deepen, and they get steered right up the coastline like cars funneled onto a single on-ramp. That is the first solved piece. The alert is not about one system. It is about the road the storms are being forced to travel. But a buckled jet stream on its own does not stay put. Something has to hold it there. And that question, what is anchoring this pattern, is where the trail got genuinely interesting. Because the thing that locks a jet stream in place has a name, and it has an index that forecasters check like a stock ticker. Let me show you the second clue. It sits far away from the East Coast. It sits up near Greenland and Iceland, in a piece of the atmosphere called the North Atlantic Oscillation. NOAA tracks it as a single number that swings positive and negative, and that number quietly runs a huge share of winter weather for the eastern United States. When the North Atlantic Oscillation goes positive, the flow stays fast and mild. Storms slide out to sea. The coast gets a glancing blow at worst. But when it swings negative, when a stubborn dome of high pressure, a block, sets up near Greenland, everything downstream changes. That block acts like a boulder dropped in the river. The flow cannot go through it, so it goes around it, digging that deep southern trough over the east and slamming the door on the fast west to east motion. Storms that would have raced offshore instead stall, strengthen, and ride the coast. Meteorologists have known this for decades. The relationship between a negative North Atlantic oscillation and East Coast storminess is one of the most studied links in all of American weather. And when I checked the ensemble guidance, the dozens of model runs that the Weather Prediction Center leans on to see the range of possibilities, the signal leaning toward that negative block state was exactly the blocking signal that forecaster had flagged in plain text. So now 2 clues line up. A buckled jet stream over the east and a blocking mechanism near Greenland trying to hold it in place. Together, they explain why the alert stretches across 10 days instead of 2. A single storm lasts a day. A blocked pattern is a season compressed into a week and a half. Here is the part that gave me pause, though. A block does not just make storms slower. It changes what kind of air they pull in, and the air being dragged down the backside of that trough is coming from the north, cold and dense, right as coastal storms are trying to spin up over water. That collision, cold air over warm coastal water, is the engine of the storms the Northeast fears most, which raised the obvious next question. How warm is that water right now? Hold that thought, because it becomes the last clue, and it is the one that changes everything. But first, I have to stop and talk directly to someone. Maybe you are watching this from Ohio, or Tennessee, or somewhere well inland, and you are thinking, this is a coastal problem, a beach town problem, something that will never reach your driveway. I need you to hear this part especially, because the data says the opposite, and this is the piece the forecast graphics almost never spell out. When the jet stream digs that deep trough over the east, the cold air and the wind field do not politely stop at the shoreline. A strong coastal storm, the kind meteorologists call a bomb, when it intensifies fast, throws a wind field that can reach hundreds of miles inland. The National Weather Service issues high wind warnings for interior counties during these events all the time, and those winds are what bring down trees onto power lines. Here is the concrete thing you can watch for, and it costs you nothing. When a coastal low deepens, the pressure drop is measured in a unit called the millibar. If forecasters start describing a storm dropping 24 millibars or more in 24 hours, that is the official threshold for what is called bombogenesis, explosive strengthening. That single phrase in a forecast discussion is your cue that the wind field is about to expand and that inland counties are in play, not just the coast. The second thing you can do is find your local National Weather Service office forecast discussion. Not the app, the discussion. It is free, it is public, and it is written by the meteorologist on shift in plain language, explaining exactly what they are worried about and how confident they are. When they write that confidence is increasing in a high impact event, that is the moment to check your flashlights and charge your devices days before the storm graphic ever turns red. And if you live anywhere the ground can saturate, watch the rainfall totals in the Weather Prediction Center's excessive rainfall outlook. A slow, blocked pattern means rain that does not move on. 2 inches falling in an hour runs off. 2 inches falling, and then 2 more the next day, on ground that never drained, is how inland flooding starts far from any ocean. So this is not a somewhere else story. A blocked pattern is a whole region story. The coast takes the storm surge and the worst wind, but the interior takes the falling trees, the power outages, and the flooding rain. The evidence covers a lot more ground than the headline suggests. If you want to go even deeper on how these patterns are built and why they matter, I want to mention something quickly. I put together a digital book available under the titles Storm Signal, Storm Intelligence, and Storm Alert that walks through exactly this kind of source-level reading. How to find the real forecast products, how to interpret the signals forecasters actually rely on, and how to connect the dots between the atmosphere, the ocean, and the storm you are about to live through. It is the same framework I use every time I sit down with a new case, written so that anyone can follow it without a meteorology degree. You can find it linked in the description below. Now, back to the trail, because the next clue is the one that changes the entire picture. Now, with that settled, let me take you to the clue that turned this from a normal forecast into something I could not stop reading about. And it comes from a paper written before satellites even existed. In 1946, a meteorologist named J.E. Miller published a study in the Journal of Meteorology titled, roughly, on cyclone formation in the Atlantic coastal region of the United States, nearly 80 years ago. And in it, he did something that forecasters still use today. He sorted East Coast coastal storms into two families. He called them Type A and Type B. A Type A storm forms down in the Gulf of Mexico or off the southeast coast, and then rides north along the seaboard as a single organized system. It is the more predictable of the two. You can see it coming days out. A Type B storm is the tricky one. It starts as a weakening system over the Appalachian Mountains. The mountains actually tear the original storm apart, and then a brand new low-pressure center redevelops offshore near the coast and rapidly takes over. The energy jumps from the dying inland storm to a fresh coastal one. That handoff is called secondary cyclogenesis, and it is one of the hardest things in the business to forecast because the storm that hits you is not the storm the models were tracking a day earlier. When I read Miller's framework and then went back to the modern forecast discussions, it clicked. The pattern being flagged for the next 10 days, trough over the east, cold air behind it, energy diving into the coastal zone is exactly the setup that produces these coastal redevelopments. The reason the alert window is so wide is that forecasters cannot yet tell you which individual system becomes the big one. In a blocked pattern, they get multiple chances at bat. One weak-looking system crossing the mountains can hand its energy to a monster off the coast in a matter of hours. That is why the professionals talk about the pattern for 10 days, rather than naming a single storm. They are watching for the handoff. They are watching for a Type B, and Miller told us where to look for it back in 1946. Most coverage will never mention his name, but every forecaster staring at this setup is, whether they say it out loud or not, using the map he drew. So here is where the trail stands. A buckled jet stream, a block near Greenland holding it, a classic setup for coastal storms that can redevelop and explode with little warning. Every clue points the same direction. But there is one variable I kept circling back to, the one I asked you to hold on to. Because a storm setup is only half the equation. A storm needs fuel. And the fuel for a coastal storm is heat and moisture rising off the ocean surface. So I went and found the number. And this is the reveal, the piece sitting in plain sight that reframes the entire next 10 days. The water off the East Coast is not running at its normal temperature. For the last few years, NOAA's own monitoring the satellite sea surface temperature analysis and the network of buoys maintained by the National Data Buoy Center has been recording ocean temperatures along the northeast continental shelf running well above the long-term average. In some stretches, sea surface temperatures have run several degrees Fahrenheit above normal for the season, and there is a specific piece of ocean that makes this dangerous. The Gulf Stream, that warm current that carries tropical water up from Florida and along the eastern seaboard before bending out into the Atlantic, has been the focus of study after study. Research, led by scientists at institutions including the Woods Hole Oceanographic Institution and Rutgers University, has documented that the waters of the Northwest Atlantic, including the Gulf of Maine, have been warming faster than most of the global ocean. The Gulf of Maine in particular has been described in peer-reviewed work as warming faster than roughly 90% of the world's oceans. Now connect that to everything I just walked you through. A coastal storm intensifies when cold air pours over warm water. The bigger the temperature contrast between that dry, cold air diving down the back of the trough and the ocean surface it crosses, the more explosively a storm can deepen. Warmer than normal water is not a small detail. It is extra fuel loaded into the exact machine the blocked pattern is building. That is the buried finding. The alert you are hearing about frames the danger as a weather pattern in the sky. But the variable that decides how strong these systems get is sitting in the ocean, measured, logged, and mostly left out of the headline. Colder air aloft than normal, warmer water than normal, and a jet stream configuration that forces them to meet right over the coast. I sat with that for a while, because it means the models may actually be underselling the ceiling on these storms if the water is running warmer than the climatological averages baked into some guidance. Warmer water means more evaporation, more moisture pulled into the storm, more latent heat released as that moisture condenses, and a lower central pressure. Lower pressure means stronger winds. It means the difference between a nuisance and a bombogenesis event of the exact kind Miller described. And you can watch this yourself. NOAA publishes sea surface temperature maps for the Atlantic, updated constantly. The National Data Buoy Center posts live water temperature readings from buoys off the coast, free to anyone. When a coastal storm is forecast and you see that the water it is about to cross is running above normal, you have just read the same warning sign the forecasters read the fuel gauge sitting under the storm. That is the full picture. Not one storm. A blocked pattern that refuses to move, a jet stream folded into a trough, cold air riding down the back of it, a coastline set up for the hardest to forecast redevelopment there is, and an ocean underneath running warmer than the calendar says it should. Every one of those pieces is real, measured, and attributable. Put them together, and you understand why forecasters are talking in terms of 10 days and not one afternoon. Let me be careful here, because I promised you I would never claim more than the evidence supports. Nobody, not the Climate Prediction Center, not the Weather Prediction Center, can tell you today the exact track and strength of a storm 9 days out. That is not how the science works, and anyone who tells you otherwise is selling you something. What the evidence supports is the pattern and the ingredients. The trough, the block, the temperature contrast, the coastal setup. Those are what the professionals are flagging, and those are what you can verify for yourself in the public products. But here is what I keep coming back to. The information that matters most in the next 10 days is not on the weather app on your phone. It is in the outlooks, the discussions, the buoy readings, and the ensemble signals that are all public and almost never surfaced. The tools that told me the story are the same tools sitting one search away from you right now. So watch 3 things over the next 10 days, and you will be reading the situation better than most of the people around you. Watch the Climate Prediction Center's 8 to 14 day outlook to see whether that blocked cold in the east signal holds or breaks down. Watch your local National Weather Service forecast discussion for the words describing rapid intensification or a coastal redevelopment. And watch the sea surface temperatures off the coast, because that is the fuel gauge nobody is showing you. If those 3 line up, the block holds, the discussion warns of a deepening coastal low, and the water is running warm, that is your signal to take the alert seriously wherever you live. Not to panic, to prepare, to charge the devices, to clear the storm drains near your home, to know where your flashlights are, to check on the neighbor who would not. Here is the emotional core of what I found, and I want to leave you with it plainly. The next 10 days are not being decided by luck or by some vague sense of bad weather coming. They are being decided by a handful of specific, measurable things. A fold in the jet stream, a dome of high pressure near Greenland, a pattern first mapped in 1946, and the temperature of the water off the coast. Most people will feel the storm and never know why it was so strong. You now know why. You can see the machine before it runs. That is the whole reason I do this. Not to scare you, to hand you the same primary sources the forecasters read, so you are never at the mercy of a watered-down summary that leaves out the one number that mattered. And if you are the kind of person who would rather understand the actual mechanism than be told to simply stay tuned, then you already belong here, because that is exactly who this is for. So tell me one thing in the comments. Go pull up your local National Weather Service forecast discussion and tell me if you see the words trough, block, or coastal low in it, and tell me what state you are watching from so I can see how this pattern is showing up near you. I read them. When enough of you report the same signal from different coastlines, we can see the whole picture take shape in real time. If you want the real evidence dug out of the source documents and explained before the headlines catch up, this is the place for it. Because the next case I am already digging into is the one nobody wants to connect to this. What happens to that same warm coastal water when hurricane season arrives, and why the exact temperature anomaly I just showed you may be the single most important number on the map months from now. I found the first thread on that one already, and it is not what the summaries are telling you. Stay with me. Read the source. and watch the water. I'll be honest, the story doesn't end here. Inside my membership, the Weather Watch, I take this exact forecast deeper, showing what that block really means for you. And if something worries you, ask me directly. I answer you myself. No robot. And you won't be watching alone. You'll belong with storm watchers like you. Just point your phone's camera at the code on your screen. Cancel anytime, one click.